Hello and welcome everyone in this YouTube channel, Mausam Science. Today, we are going to discuss about the practical of physics, that is about the operational amplifier. Our main intention is to generate the different types of wave, like square wave, okay, um, to generate square, rectangular, and a sawtooth wave signal in our physics laboratory. Okay. Before this, we need to know about the operational amplifier. What type of device is this? Okay, so I will go through this definition. An operational amplifier, op-amp, okay, in short, we call it as a op-amp, is an integrated circuit. It is a type of IC that amplifies the difference between a two input voltage. If there is a difference between, okay, um, here, okay, this is the 741 IC, which have of 8 different pin, okay, and here there is a circuit of op-amp. Okay, from 2 we are giving the inverting input, and from 3 we are giving the non-inverting input. One is negative, another is positive. So if there is a difference between two input voltage, okay, then it amplifies the output. Okay, we know from this definition an operational amplifier is an integrated circuit that amplifies the difference between the two input voltage. What is the difference between the two input voltage? Okay, that voltage will be amplified by this op-amp. Okay, it is a fundamental building block in analog electronics. Okay, it is the main component of electronics. So here I can say that 2 number input is negative inverting, and 3 number input is positive non-inverting, and from 4 number, okay, we will give a power negative power supply, that is minus 12 volt, and from 7 we'll give a positive power supply, that is plus 12 volt, and from 6 we'll take a output. Okay, if we place okay, this is the general formula, and how to identify whether this one is first number pin and whether that one is first number pin. Okay, so for this purpose, okay, for this purpose, what we will do, if we place the IC 741 IC in such a way that this pointer points towards your left side. Okay, if you place this IC in this position, another position, if you place the pointer in the upward side, okay, like this, then the left hand side will be 1 2 3 4, and from down we'll get 5 6 7 8. Okay, but you choose this type of point in the IC, place it upward, not downward. Okay, if you place it downward, the this numbering will be reversed. Okay, and you need to identify which one is 1 2 3 4 and 5 6 7 8. We need only 2 3 4 7 and 6 as a using terminal. Okay, in this IC. Now, basic characteristics. What is the characteristics of a op-amp? Okay, we'll get a high gain in this op-amp. Okay, op-amp have very high open loop gain. Okay, typically ranging from 10,000 to millions time. Okay, we'll get this gain of op-amp according to our setup. And another, it have a high input impedance. Okay, it prevents the op-amp from drawing significant current from the input signal source. Impedance means a type of resistance. Okay, which will be applied in a AC circuit. Okay, impedance is a type of resistance. Okay, now what we call it over here, it have a high input impedance. Suppose it have a high impedance over here, then it draws a less amount of current, okay, from the input signal source, from where we are giving a signal. It draws a less amount of current, and it have another low output impedance. That means it have a low output impedance, so that it gives a more amount of current to the driver. Okay, to what it operates. Low output impedance means this allows the op-amp to drive load with the minimum signal loss. There will be no any signal loss. Okay, less amount of current will be drawn, and more amount of amplitude will be supplied. That is, it have a high gain. Okay, this is the working mechanism of a op-amp. And configuration of op-amp: inverting amplifier, non-inverting amplifier. We can use it to make a inverting amplifier, non-inverting amplifier. Okay, voltage follower, buffer circuit. Okay, and a summing amplifier. Okay, and another as a differential amplifier. Okay, we can use. And what is the application of this op-amp? Its application is a signal conditioning, that is amplifying a weak signal before that further processing. If the signal is weak, we need to amplify with the help of op-amp. Active filter: it can be used as a low pass filter, high pass filter, band pass filter, and band stop filter. Okay, we have discussed about this filter, but without using op-amp, with the help of a resistor and capacitor. Okay, you can view that video in the upper I button. Okay, in this video, and the lower description box as well. Oscillator: okay, it generates a waveform like a sine, square, triangular wave. Okay, as well. And in our context, we will see about the square and triangular wave, and also the sawtooth wave, which is generated by this type of op-amp. Analog computation: okay, it is used for the analog computation, like as addition, subtraction, integration, differentiation. Another is it is used as an instrumentation, enhancing the accuracy and stability of a measurement system. Okay, this is the fundamental thing to be known about the 741 IC. Now, I hope I can move towards our experiment to generate a square, rectangular, and sawtooth. Okay, but in my experiment, these two diagram may not be drawn in this IC. Okay, 7 and 4 terminal. Don't forget to supply from 7 terminal 12 volt, and from 4 number terminal you need to supply minus 12 volt. Okay. Here it is also mentioned with the dotted line so that it should be remembered. Now, mm, this is our experimental circuit to generate a uh, oscillator. Okay, to generate this one. Uh, this is a circuit which helps to give out the square wave outcome. Okay, square wave outcome can be given by this circuit. For an example, this is a op-amp. From 2 number, we'll connect our 0.1 microfarad capacitor and take it to the ground. Okay, we can do as well. This is a color. The code of this capacitor is 104. And from this 3 number terminal, we can use a 10 kilo ohm resistor and take it to the ground. And again, this is the value of R2. And from here only, we can take a 10 kilo ohm resistor and connect it to the B output. That is 6 number terminal is output. Always there is 6 number terminal as output, as I said already before. And from this 7 number point, we'll supply plus 12 volt. And from 4 number point, we need to supply minus 12 volt. Okay, this should be remembered. 2, 3, 2 is inverting terminal. 3 is non-inverting terminal, 6 is the output, and other connection can be done as well. And from here, 2 number terminal, we need to take a 10 kilo ohm resistor and connect it to the output voltage. So as a result, if we take a oscilloscope and measure the voltage from here, okay, measure the voltage from here, and what type of waveform can be seen in the oscillator? We can see a square waveform. Okay, here the drawing is not clear. Square waveform can be seen. This line is straight. Okay, assume it to be straight. We can see a square waveform like this as output. So this is the type of relaxation oscillator which produce the output as a square wave. Okay, we can do this in our experiment. It is simple. This is the IC741, and I have told you where we need to connect different type of terminals. Okay, let me clear my drawing. Okay, now the another one is comparator circuit. Okay, we need to make a comparator circuit so that it gives the rectangular wave as a output. Okay, we can see here from a signal generator. Okay, a sinusoidal voltage will be supplied from 2 number terminal, and from 3 number terminal we need to supply a plus 5 volt, okay, in the upward direction, and downward we need to supply the ground. Okay, and here, okay, in this circuit, what we need to do is we need to connect a 10 kilo ohm potentiometer. Through potentiometer, we'll supply in this 3 number terminal. Okay, through a potentiometer. Potentiometer, I have told you there are 3 different terminal in potentiometer. Okay, make a drawing. Okay, in potentiometer, we have a 3 different terminal. Okay, to control. We can take this as a ground. Okay, this can be ground, and here we will supply this 5 volt. Okay, nothing but this overall circuit. I'm talking about this. Okay, from here we'll supply 5 volt, and from here we'll give output to this 3 number terminal. Okay, only this means. And from here, if we get this output, okay, here we have supplied voltage in input voltage as a sine wave. This is our input voltage type. It will be provided through a signal generator. Okay, you connect a signal generator, low voltage sine wave, and after that we can see the output as a rectangular wave. Okay, from here, if we take it to the oscilloscope, and from here, if we take the oscilloscope, 1 number probe over here, okay, 1 number probe of oscilloscope over here, and the 2 number probe of oscilloscope over here, then what even is, we need to get this type of input, and as a result we'll get this type of output. Okay, now this is a circuit diagram to understand a comparator circuit to generate a rectangular wave. Okay, video is not working. Okay. I hope this screen is visible to you now. What happened to this? I have a pause in my screen right now. Let me make it. Okay. The another one is we need to generate a sawtooth generator. Okay. But before that, we will generate a triangular wave also. Okay. We'll say triangular wave. Now for that, we need to give a supply. Okay. This is nothing but as a circuit which we discussed in a square wave signal. Okay. Whatever circuit we have made in a square wave signal before. Okay. This is the same circuit. Okay. Like this square wave. So as a result, this circuit will make, okay, and this is the output of a square wave. So we will supply this output of a square wave to another resistor 10 kilo ohm and supply that to the two number pointer of IC 741, and from this two number pointer will connect the capacitor 0.1 microfarad and connect it to the 6 number terminal, and from 3 number we'll connect it to the ground, and 4 and 7 as well. I told you that plus 12 volt and minus 12 volt will be supplied. So here we will get a square wave signal. And what type of signal we'll get in this terminal after this arrangement? We will get a triangular wave like this. Okay, so this is the circuit using op-amp to generate a triangular wave. Okay. Now another is this one to generate a sawtooth generator. Okay, so for this we will supply a rectangular wave. Okay, we'll supply a rectangular wave, and after that we will get our output as a sawtooth generator. As we see this circuit, okay, this circuit and the other circuit which will generate a rectangular wave, these two are same. Okay, whatever may be the figure, you will make this circuit and your output will be a rectangular wave, which we have already talked. Okay, already discussed. Our this circuit output will be rectangular wave, and from here you connect a 10 kilo ohm resistor. Okay, and from here 6 number terminal you connect 1 kilo ohm resistor and take it to the transistor. We'll use here one transistor, and from this transistor what we will do is collector, and from emitter and collector will connect one capacitor, and from emitter will give supply to this 2 number terminal of another IC. Okay, and from collector will give supply to the 6 number terminal of this same IC. Okay, op-amp, and from 3 number we'll take it to the ground. So as a result, if we see here as an input, okay, this we have already discussed. Okay, use your potentiometer if possible. Okay, and we will see this as an input wave, and here we will get as a rectangular wave. Okay, we have already talked. Okay, and as output from here, okay, B out, we will get a sawtooth wave as an output wave. Okay, I hope the experiment is clear to you, because the IC is clear before. If the IC is clear, then other concept will be clear. Okay, and the supplying voltage plus from 7 will supply plus 12 volt, and from 4 will supply minus 12 volt. So as a result, our experimental setup to is completed, which helps us to generate square wave, rectangular wave, triangular wave, and a sawtooth generator. So after saying this much, I would like to end my discussion over here. I am sharing my knowledge. It may not be 100%, but whatever I acquire, okay, the knowledge I'm going to share you, I shared with you. Okay, so if you like this video, then please leave a comment and share it to the others, okay, who need it. Actually, we'll meet again. Bye bye.